And we are live. And I wanted to take an opportunity. My name is Jeff Good, and I'm with ITIP Ohio. And with me is Tom and Lauren from Gibsonburg. And is that Gibsonburg Local Schools?
Gibsonburg Exempted Village Schools.
You're an EVP. Okay, great. So I'm going to just step through some of the questions, and Tom and Lauren were part of our showcase project, and I certainly appreciate your time. So if you wouldn't spend an opportunity real quick to give each of your names and what your project name was.
I'm Lauren Stewart, and I did a project with my 8th grade science class where we answered the driving question, is the dominant trait always the most commonly expressed trait?
And Tom, what did you do?
I did a project with my honors physics students where the driving question was what variables contribute to efficient catapult design and how to optimize those variables.
Now I'm going to go to Lauren first and say, Lauren, what were some of the major steps of that project that you worked with?
So the first thing we did was we just discussed the idea of traits that we can observe around us every day. So we kind of looked around the classroom, looked at what makes everybody different, and then took a quick little survey and said, okay, how many of you have dark hair? How many of you have dark eyes? And asked the question, well, based on that quick survey, what we see in the classroom, could we decide what the dominant and what the recessive trait is? And they weren't really sure. And this kind of plays off that misconception that just because something is the dominant trait, it's the one we see most often. Because in colloquial terms, when we say dominant, it usually means more common, but that's not necessarily true in science. So my students picked a set of traits they're going to study, and then they did a little bit of research on all of them so that they knew each group had a trait and they needed to know what the dominant trait was and what the recessive one was. So, for example, they could have done dark eyes or light eyes, dark hair, light hair, cleft chin, no cleft chin, etc. Then each group made a survey question that went with that trait. And their survey question just had one of two answers, an answer that either went with the recessive or an answer that went with the dominant trait. So it was really easy to tell when people answered whether they had the recessive or the dominant. And then we put all those survey questions into a Google form, and I had them post the link to the Google form on all their social media accounts. And I posted on mine as well, and we sent it to everyone in the district. So we actually had over 200 responses to our survey, which was pretty cool. They were surprised by that. They didn't think as many people would respond. And then they each got a chance to pull up all of that data using Google Sheets, which is nice with the forms because Google Sheets automatically dumps all that data into charts for you. So they each were able to visualize for their question what percentage of people had answered for the recessive or dominant trait. Then they analyzed their data, came to a conclusion about just their trait, whether the dominant or the recessive was more common. And then we compiled all the class data and came to a conclusion as a class that no, the dominant trait was not always the most common trait. And then each group put together a set of slides that we made as part of a class slideshow that summarized their conclusions. They summarized what their trait was, what their survey question was. They showed us a graph of their data, told us what their conclusion was, and then we wrote our class conclusion together and then posted the link to that presentation on social media again so people who participated in our survey could see what our results were.
That sounds like a wonderful project. Tom, I don't know how you can follow up on that. So Tom, you want to talk a little bit about the major steps of your project?
Yeah, my students started off by doing a little bit of background research on catapult construction, and they just kind of brainstormed together 7 or 8 variables that could possibly affect the length that a projectile could be thrown by a catapult. And they came up with some things that were really, really important, like angle of release or arm length or rubber band placement. And then they had some other things that were less important, were more dependent on their individual construction, like the mass of the projectile being launched or air temperature. Some of them had some strange or minor variables, but each group ended up selecting a variable for themselves to test. And so they each built a catapult at that point, and to test specifically their variable. So they were testing angle of release. They made a catapult which had a variable angle of release, and they all used technology in some way at that point to measure how far they launched their projectile or to ensure that they were actually firing at the correct angle that they were desiring. We used a program called Logger Pro to analyze video analysis taken by their phone. We put the video into Logger Pro and analyzed it to make sure that it was launching at the correct angle for them. And use that also to figure out how far the projectile was launched, because when you just look at it, you can't really tell right away how far it went. And then each of them made a presentation of the class on a whiteboard. They compiled some data, made a chart, and analyzed that. Some of them were linear relationships. Others had like an optimal angle. So the people who did angle, they saw that 10 degrees, 20 degrees, 30 degrees, it was getting better and better. And then after 45, it started to decline. And so they were able to say from their graph that the optimal angle of release would have been 45 degrees, which is actually a correct statement too. So that was kind of cool to see. And so after each group presented their individual variable, each group was challenged then to construct their own optimized catapult. So knowing what we know now about all 7 of those variables, how do we make the best possible catapult? And so they were all turned loose with given a specific amount of supplies, and were told to make the best catapult possible, knowing those things. And their final project was to launch it, but after that, to film their launch and then to make a tutorial video on what they learned and how to construct an efficient popsicle stick catapult. And so they all posted those to YouTube, and anyone who wants to can just Google that and find their videos.
Great. Well, those are, wow, I tell you what, 2 very diverse projects. That's outstanding. Now I'm going to talk a little bit now and ask you some questions about yourself. So when you think about the project and what you've done, what would you say is the most important thing you learned in this project? And I'll start with Tom.
The most important thing I think I learned was just what the students are capable of, given high expectations and time to do that. I was really impressed. Some of my physics kids, with only a handful of popsicle sticks and 3 rubber bands, launched a steel ball bearing like 15 meters. That was like half the length of the gym. I never expected anyone to get a launch that long. That was really impressive, and I have to give them all the credit for working hard to not only find the variables in the right angle, but to optimize their individual catapult and achieve that insane launch.
Lauren, what did you learn was probably one of the most important things from this project?
I think this project really challenged me to get creative with my integration of technology into this lesson. I remember when I originally came up with the idea, it was adapted from something I had found online, and I was going to have the students write a paper survey, and then we were going to mail it to some other districts for some other science teachers I know, and the students would fill it out and they'd mail it back. And that was fine. But in this day and age, there's just not a need to do that, to actually mail things. So then when I had the idea, like, wait, we could do this on Google Forms and we could put this out on social media, which the kids use every day, and we could get a ton of results back in a day. It was just like this great revelation, and it turned out so well. So I'm really excited to use that method of collecting data again.
That's neat because I just wonder, I talk with a lot of students, and for them to figure out where you buy a stamp, I thought when you just made that statement, I thought that was very interesting because I know I've talked with students, and when they have the whole concept of how do I send something, finding a stamp is very interesting. Well, I'm going to stay with you, Lauren, and say, what do you wish you had spent more time on or had done differently in relation to the project?
I wish I had maybe spent more time in the beginning really developing that driving question, and maybe spent some more time in class discussion and more time having them really deep in the project design. They did a really good job once we got them started and they got their questions and they collected the data. But I found towards the end, when we were coming up with conclusions, I wish that I had spent more time really making sure we had really delved into that driving question in the beginning.
How about you, Tom?
There's probably 2 things I think I wish I'd spent more time on. The first one was being very careful about the variables that we selected, because one of them that wasn't selected that should have been was like design style, because the one that ended up winning had a fulcrum in the middle and then the rubber bands attached to the base and then flipped it. And almost every other construction had rubber bands, like they had a different class of lever as a firing arm. So we never looked at what class lever affects firing length. I think we would have found that important variable had we done that. Another thing I wish I'd spent more time on was developing our expectations for what should be in the video, because my kids did an excellent job collecting and analyzing data and using technology to do that. But then when they went to make the tutorial videos, they didn't really talk about the data that they had um, collected and analyzed. They didn't really discuss how the relationships that they were trying to establish had been derived. Um, Especially that 45-degree angle group. I thought that it would have been really awesome for them to put their graph in their video to show like we did all these trials to show the right angle, and then they just said we wanted to fire at 45. They didn't tell why they wanted to fire at 45.
I'll start with Tom now. What part of the project did you think you did your best work on? And maybe you've answered that already.
I think the best thing that we did was using Logger Pro to break down our variables, because almost every group, some of them couldn't be done, but almost every group used Logger Pro and the video analysis feature of that, like just like the Mythbusters do, to derive their relationships, to collect their data, and to actually be able to start with um, a good analysis of their variable. I think a lot of times we just kind of revert to stopwatches and meter sticks, and you can get a lot more accurate data when you use video analysis and Logger Pro. So incorporating that piece and really focusing on that for both the incorporating Logger Pro into data analysis for their individual variables was probably the best part of it.
How about you, Lauren? What was the best part of the project?
I think the use of the Google Forms and integrating that with social media to collect such a large amount of data in really 72 hours. We let it run over a weekend, came back, had enough data to analyze. And that was really good for the students to see that, you can collect data, a large amount in a short period of time, and you can analyze it. You can be scientists. Like what they did was a great scientific experiment, and they didn't have to do any lab work or anything crazy like they think scientists do to do it.
So let's talk a little bit about the project. And I'll ask both of you, and Lauren, if you want to go first, what was the most enjoyable part of this project?
I think the funnest part was just the chance to be creative and to really build this project from scratch and make just something you're really proud of, and something that maybe is a little outside of the box from what I would usually do. This is my first time teaching Science 8. So it was a little bit intimidating because I wasn't super familiar with the content getting into this, but I feel like it really helped me dive into what the eighth grade science standards were and really helped me come up with a creative lesson plan that I probably wouldn't have come up with otherwise.
How about you, Tom?
I think the most enjoyable part for me was just watching them launch their final projects at the end, because we had cameras taking video from two different angles just because they wanted to analyze it in Logger Pro when they were done, and just seeing them like launch the final products and be competitive and joke around with each other and see how far their projects went. That was really fun.
Great. Well, we'll go to the other side then. I've got Tom going here. And what would you consider one of the least enjoyable parts of the project, if you had any?
Nothing comes to mind. You want to go first on that one?
I think with the age group I was working with, sometimes it was just difficult to get them all on the same page and get a discussion going where they were actually thinking and engaging their minds and really designing a scientific experiment, because it's not something they were used to. So it wasn't necessarily unenjoyable, but there were definitely some parts of it, because we weren't just doing your basic, here's a worksheet, here's a video, here's, whatever boring thing I'm going to give you. We were actually engaging their minds. So it was a little more difficult at times than something else would have been, which I don't think was a bad thing. It just was a challenge at times.
Yeah, I'm actually going to have to agree with that. Even with an honors physics class, the cream of the crop at our school, so to speak, it was still a little bit difficult to manage during those discussions because they wanted to go off and get right to work on their catapult. They didn't want to sit and talk about it. They wanted to just go and do it. So they were already chatting, they were already sketching, they were already getting their projects scraped together, and I was still trying to have them explain their variables to each other.
What would you change if you were doing this project again? What would you change to make it a better one when you talk about the project?
I think I would spend more time in the beginning really developing that question and maybe trying to get the students to even come up with that question themselves. I led them to it, but I think I could do more to really get them to buy into it. I felt like they understood it and they understood why they were doing it, but they weren't really buying into, okay, this is a really important question that we need to answer. And they didn't really buy into the fact that they had a really big misconception about it. So I think just really spending that time to set it up in the beginning would be helpful for next time.
Tom,
Yeah,
any
I'm
thoughts?
definitely taking time to develop the expectations on that final product video like earlier than I did, because a lot of them, by the time they actually realized what they needed to make for the finale, had already built half their catapult and missed the opportunity to record their footage of them building the side structures or the non-lever arm part of their uh, catapult. So I would have taken more of an opportunity to let them know what I expected out of their final project. And Tom has some feedback here from a tech and a curriculum director standpoint. He says that he would have liked to see more uh, technology staff information on any tech support or I'm trying to read this. Provide the technology staff more information on any tech support or connectivity requirements that may be needed.
Okay.
Sounds technical.
Um, well, I know you've talked about it. So both of you talked about so far, and I've heard everything from Google Forms to your graphing program. And I know I'm going to mess up the name, but what are some other technologies that you integrated into your project, and were there some things that you did differently in order to integrate that technology?
Yeah, in addition to using Logger Pro to analyze data and to break it down and to actually show relationships, for their final product, they had to make that video, which was um, like an instruction manual that was digital, so that anyone who's building a popsicle stick catapult can go to YouTube and look up like a how-to manual that would be written by them. So they had to use technology to record their videos, to edit their videos, and then again to publish their videos as well. So really, at every stage of this project, they were like wrapped up in the technology piece, which I think that was, and Tom agrees too. That was another feedback he gave, is that Laura and I did a really really good job incorporating the uh, technology into really every step of our project that we possibly could.
Yeah, I think I wish there are some places I could have incorporated technology more, but it was a hard time of the year when I was completing mine because we were in the midst of park testing. So I
Oh.
actually had to borrow laptops from NWOET to complete my project because all of our Chromebooks in the school were being used for first round of park and AIR testing. So I would have liked to have had my students collect even more data on more traits and had them work in partners, but I just didn't have the computers to allow my students to do that. So I think with what we had, we did really well. We also got the opportunity this year to use the iPads that we got with the program, and we bought an Apple TV that's just ours personally. And our technology director ran VGA cords out of our projector so that we could bring in our Apple TV and mirror it on the board. So that was really useful this year just to show them some things. There's some really neat apps that we found for even just beyond the scope of this project that have been really fun to show the students that we didn't have the ability to use before.
Yeah, a lot of my students actually use my iPad or the iPad that we got for uh, filming their initial launches, so they could again verify they were launching at the right angle, the right speed, all that good stuff.
So let's talk for a minute. This is the last question. What would you say is the impact of this technology as you looked at the tech integration, and talk a little bit about that impact on you, and how about that impact, the technology integration on your students?
My students were blown away by the fact that they could take a video of something they built on their phone, put it into a computer, and analyze that in terms of velocity, acceleration, the X and Y directions. Um, they can basically do what they see happening on MythBusters or Sports Science, these TV shows they like, the science ones. They can do exactly what those people are doing in the same program that they're doing with the same equipment that they have in their pocket every day. So they were just absolutely astounded by what they were capable of doing just with their phone and a computer program. A lot of them actually have even, because the Logger Pro site license is so generous, they can download Logger Pro to their own personal laptop. So they're going to take that with them as they leave the class. If they ever get the desire to analyze the motion of some strange object, they have the ability and all the tools at their disposal to do that. So um, that was really cool to see that.
How about you, Lauren?
I agree. It's really cool to see students excited about it. When I came in on Monday morning and asked them, how many people do you think responded to your survey? And they're like, I don't know, maybe 50 if we're lucky. And I told them they had over 200. I think we had about 240 people respond to the survey. They didn't believe me. They're like, nah, who responded to that? That's not real. But they did a really good job and they collected all that data and it was really useful. That was cool to see them excited about what they had done. And I think this year for me has been a really big year in adding more technology into my classroom. And this project was a really good kind of platform to launch me from that, especially with the professional development we had with Judy Tucker. We just kind of told her the stuff we wanted to learn, and it wasn't necessarily related to the project, but it was just general ed tech stuff. And she came in and showed us different things to do with the iPad for a one iPad classroom, different things to do with the Chromebooks. And that was just really great. So I've been able to integrate a lot of technology into my classroom, especially with the Google Suite, using Flubaroo and Doctopus and Gubrix and SiteMaestro. And I just started using Autocrat. So I've been able to integrate a lot of stuff into my classroom this year that I haven't had previously.
Well, that was our last question. I certainly appreciate both your time, Tom and Lauren, and I wish you the best of luck. And I think that's all. So thank you.
Our pleasure.
Thank you.